Hi students, welcome to this new video on Gauss reduction. Gauss reduction is an extension of the Gauss elimination algorithm covered in your previous math classes in the first year. Now, we have to ask ourselves this important question. Why is Gauss reduction important? Gauss reduction is important because the method helps us to solve system of linear equation, and it helps us to easily compute the determinant of very large matrices, 3 times 3, or 4 times 4, or 10 times 10 square matrices. Okay, now the Gauss reduction applied to a matrix will produce a matrix called reduced row echelon form, also known as RREF, reduced row echelon form, right? And we obtain this row reduced echelon form as follows. After carrying out Gaussian elimination, we have to continue by changing all non-zero entries, right, above the leading ones to 0. Please do not be confused with the term leading ones. We will explain this in the subsequent part of this video. And then once you have done that, your resulting matrix will look like 1 0 0 0 0 0 1 0 0 0 0 0 1 0 0, and then I may have a star star 0 0 dot 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 star 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 0. So this matrix is what we call a reduced row echelon form of a certain matrix, right? Now, notice the staircase or step ladder drawn to the matrix that has all entries below it equal to 0. So let's look at the staircase or the step ladder, right? So here I will have a 1 here and a 0, right? So, and you also realize that all the entry marked by asterisk can be any value, right? Any scalar. Now, these are the entry. This is what we call the leading ones. The leading ones, right? This is what we call the leading ones. Now, you must realize that this row, this reduced row echelon form, right, must preserve some properties. For instance, if, for instance, a matrix will be recognized as reduced row echelon form if every leading entry is a leading one. So we have in the first row, this is a leading entry. So it's a 1, leading 1. The second row, leading 1. The third row, leading 1, right? You can see, yeah, leading 1. This is 1, right? Now, secondly, every entry below and above a leading 1 is 0. So let's have a look on that. Every entry below and above. So this is a leading 1, below is 0, above is 0, below is 0, above is 0. Right here, you also have below is 0 and above also will be 0. So thirdly, as you go down the matrix, the leading ones will move to the right. So you can see that as we go down, you can see as we go down this way, as we go down, you can see that the leading entry, you can see that the leading entry will the leading entry one will be moved to the right, right? And then lastly, any all zero rows are at the bottom. So you see that any all zero rows are at the bottom. So these four properties need to be preserved for a matrix to be recognized as a reduced row echelon form. Now, will you mind answering this question with me? An example, right? Let's have matrix A equals to 1, 0, 0, 0, 1, 0, 0, 3, 0. And let's have matrix B equals to 1, 0, 0, 0, 1, 0, 0, 0, 1. Let's have matrix C equals to 0, 1, 0, 7, 0, 0, 3, 0, 0. And then have matrix D equals to 1, 0, 0, 7, 1, 0, 3, 0, 1. Now, among these four matrices A, B, C, and D, which ones are or not reduced row echelon form? How do you answer that question? Do you have an idea from what we said before? Now, as solution, right? Remember the four properties that we said before that a matrix must preserve to be recognized as a reduced row echelon form. We said that a matrix is in a reduced row echelon form if every leading entry is a leading one. Secondly, every entry below and above a leading one is zero. Thirdly, as you go down the matrix, the leading ones move to the right. Then lastly, any all zero rows are at the bottom. So let's have a look on our matrices, and we can see that A and B are in their row and their reduced row echelon form, right? Because the respect that they satisfy all the four conditions that we gave just now. And then we also realize that C, right, and D, right, C and D are not in the reduced row echelon form. So why is C not? Because number one, so we have two readings. Because number one, when we go down, right, the matrix leading one does not move to the right. That's a that's for the first argument for C. And the second argument for C is that every leading entry is not a leading one. So if you look at the first row here, the leading entry is 7. It's not a leading one. So C is not in a reduced row echelon form. Now, if you look at D, you realize that at D we notice that for D that not all the entry below and above the leading one is 0. So this is a leading one here. You see that the entry below is 0, but above is not 0, right? So D is not in a reduced row echelon form. Okay, so in the next video together, we will see how to apply the Gauss reduction method and how to Gauss reduce a matrix. Why not solve any system of linear equation? Thank you.